Hi, Lucas here, and I'm going to show you how I created my double linked list in a C++. I start by demoing my linked list, how it's working with the database, and then I'm gonna show you the code behind it. So if I run the program, now welcome to the database menu, and there is the options. I added some more options that there were not in specification for the double linked list. So if I just print the database, I have it populated with some records already, and you can see that it's populated with the player records, and there is the first name, surname, some experience, and some level for the players. So if I want to insert a new record at a particular level, so I press 1 and it asks me to enter position. Position 0 is one before the first one, and any number greater than 0 is after the any number greater than the length, so any number greater than 9. If I enter 10, it will be the end. So if I just enter 0, so I want somebody to be first before Stefan. So I enter some name, for example, first name will be Philip, second name will be Manik, enter level, I enter some level for the player, let's say 85, experience 2500, and now I'm going to print the database to check if he is here. As you can see, it's inserted in the first position. Now if I want to insert somebody at the end, as I said, you can enter any number bigger than the last one. So if I enter, for example, number 100, I know that there is not 100 players, but sorry, I first have to enter 1. Now I can enter the position. Asks me to enter first name, so let's say Anna, for example. Enter level, so I just give her some level 23, enter experience 3000, and I'm going to check by printing the database, and as you can see, Anna Monikova is here. This is just to do with padding, or basically tabs. That's why it's not nicely. Now if I want to delete a record in particular position, I can do the same. So 0 is for first, and anything greater than 0 and longer than the length is for last. So if I just delete the record at a position, enter a position for delete, I want to enter the 0, so I want to delete the first one. Now I'm going to check, and Philip is not there. If I again delete, for example, 100, and I'm going to check, Anna is not there. So it's working as it should. Also, if I, for example, want to delete this Lucas, that's position 1, so I'm going to delete, and position 1, I'm going to check, Lucas is not there anymore. Now I can search the database and print the results. So I'm going to search for something. I can search by level, search by name. So for example, I want to search by level, and now it gives me a prompt. I can enter level or level range in format number, lower, and number higher. So I'm just going to search first for a single level. So for example, I take level 85, for example. Now it found a player at level 85. Okay, I'm going to search again. I want to search by level, and now I want to range between 45 to 85, let's say, and it gives me all the players including 45 and 85. Now I'm going to search again, search by name, and please enter a name you want to find. So I'm going to, let's say, found Anna, because I know that she should be there, and it found me 2 Annas, as you can see. Also, if I just enter a search function and I want to search by level, let's say somebody enters number, then enter digit, what's gonna happen, it's gonna show me invalid input. So there is the regex. I'm going to show you implementation behind it and how it's working. So it doesn't let me do that. Also, next function is to find the average experience. Okay, please enter level. Again, I can enter a range for experience or just a single level. So let's say I want to find the average experience in the range, let's say 45 to 85, and it just gives me average experience is 7,250. If I print my database, and if you go from 45, if you take all the level, you can see that there is 18,000 and some. I checked it with calculator and it's given average numbers. Next is find and remove all duplicate entries. So as you can see, I have two Lucas. Ponic has to be first name and surname. There has to be same. So if I want to just run this query, so I'm just going to go and remove duplicates. Oh, of course I can print the duplicates first. Basically, what it's gonna do, it's gonna show me that there is somebody with name Lucas Ponic more than once in the database. Now I want to remove them, and it shows me there was one duplicate removed for name Lucas Ponic. Okay, so I'm going to print the database, and as you can see, it's only one. Now, if there is more, of course it shows you that there is more. I can just reload the program, print all of them, and as you can see that I have 1, 2, 3 of them. Yeah, so now if I run the query, it's gonna show me that the 2 duplicates were removed, and of course the last one stays in the database. It always leaves the first one in. Next is just print the database. As you could see, I printed it more times. Of course I can print the pointers because this is a linked list. So if I print the pointers, and this is how the linked list looks internally for the pointers. For example, this is the first player and this is the last. So these ones are the pointers to the data, and these ones are the pointers to previous and one after. So this one 006AA-EB8 has to be same as this one. As you can see, it is this one connects to this one. Now this one connects to this one. Of course the one that is before has to connect to previous. So this one AADAO or 0, it's gonna connect to this one, as you can see. So it's basically connecting all nodes, and the first and last are 0 or no pointers. So that should be for demoing the program. You can just print. Okay, it shows me a report. It's nicely, no memory leaks. So now I'm going to show you implementation. I start from the first file, I'm going to down to last one. Might skip some, but let's hope that I won't skip anything. So this is my implementation of the doubly linked list iterator. I should probably start with the node, so that will be better. I start with the doubly linked list node. This is the implementation of my doubly linked list node. So that's one node that is connected to another node, and that's what basically creates a doubly linked list. So this is the class doubly linked list node. Is it a templated class? And there is the private data members. Is the data, node data, previous and next pointer. Of course there is the constructors, default constructor, partial, and then full constructor. As you can see in here, I'm passing by R value reference. This is the basically new function of C++11, and it's instead of copying the data, it will forward it and move data from one. Basically you construct the data, for example a string. That string contains the characters, and instead of copying all of the characters, I'm just gonna use all of these old string characters for a new string. So basically it speeds the program. Of course I have a demo, I show it how much faster it is if you use it this way. Then I have a Constructors, then I have a get data, set data. Again, I can set it by moving. Has to be the templated function though. So I will also comment on complexity of my code as I go along. So this is just basic constructors, basic getters and setters. So I don't think so there is anything interesting in the doubly linked list node. Of course, getters and setters are all constant order. So I go back to my iterator. So this is doubly linked list iterator class. It's basically the class that moves from node to node. What it is, there is defined type of doubly linked list node of a data type, and I call it double node for convenience. And it basically has only one private member, and it is double nodes of doubly linked list node of data type pointer to a node. Then I have overloaded operators, again for simplicity and understanding. So I have operators plus plus, which one is the prototype for plus plus r, second is for r plus plus. Operators equals, doesn't equal. Then I have this overloaded operator, just simple plus, that it will move basically as much of the nodes as I want, and it takes constant int, so that's the number that I want to move from. For example, if I want to skip 10 nodes, I just pass 10 and it skips 10 nodes. I show you implementation. Then I have just get pointers, set pointers, basic getter setters is valid. This item is basically whichever data I want. I press my iterator.item and it gives me the data of the node that it is over. Constructors and destructors. Now I have the overloaded operators. All of these ones are constant order except the one that is a plus. This one has an order n because it has to iterate. The more I pass here, the longer it will take. So what it does is basically creates an iterator to this, and now it goes for integer I equals 0, I is less than a pinum I plus plus, and it will iterate until it's iterated to the node I wanted, or until it's not valid, in which case it breaks and gives me a warning that there is null pointer returned from my function. And I just put this stdc.ignore because it's easier to debug if your program shows you iterator invalid returning null instead of crashing and breaking, so you know where you make a mistake, where you made a mistake. Now another function is this valid. It's a constant order. Item and complexity constant order as well. All of them are basically constant order. Here print nodes, it's order n because the more you print and the longer it will take. But if you print in only one node pointers, this should be a constant order because you print in only pointers to one node, so order n will be the one function that it will use. And this is just getters and setters. Now I'm going to my doubly linked list. So this is my doubly linked list class. So I have a member variables, and what it is, it's the start pointer, so start of my list, end pointer is end of my list, and I count how many elements is in my list. And now I have defined my iterator to be delist iterator of type data type. I call it the iterator. I have setters. No, I don't have a setters and getters. I have a insert begin, insert end functions. Actually, here are the getters. Then insert that position, delete that position, begin, reverse begin. This will return the iterator from beginning or end. So if I go to my destructor, so if I call the destructor, I have to delete all of the nodes that I created in my doubly linked list, and this is order n. What it does basically, if list is not empty, I create a current pointer is the start, temporary pointer is initialized to the null pointer, while a current pointer doesn't equal null pointer. I'm going to be deleting node by node. Now I have a begin, which is just a pointer to the beginning. Reverse begin is pointer to the end. End, okay, you have to be careful what is end, because end is basically a null pointer. Is empty, just checks if my list is empty, and I'm going to insert to the begin of my list. Complexity is a constant complexity, because that will be always same speed. So if my list is empty, I'm going to be start and end pointers are new double linked list node, and I just can use forward, which is perfect forwarding, so I can just move data. So this is move enabled insert begin, or I can just use normal insert begin. It's just overloaded functions. Then I have delete begin. We just delete the first one. Again, this is constant order complexity. So if list is empty, the list is empty, nothing to delete. Else, if the count equals 1, so there is the last one. So I have to set my beginning and end pointers to the null pointers, because I want to clean my list after I delete the last node. If it's not, if there is more than one, I'm just going to create the temporary pointer. I could actually initialize it here to be a null pointer. I'm going to put into it my start pointer. So this is the temporal pointer and its start pointer. Then I have my start pointer points to the next, so basically I get next node, and I set previous node to be a null pointer because I'm deleting beginning. So previous, so my list has to start with a null pointer and has to end with a null pointer. So I'm setting the previous to the null pointer. I delete the temporal pointer, and then I just print that delete was called for my convenience and decrease the count of elements in my list. Now I have an insert end. Now I have an insert end, which is constant order as well, because I just take data I want to put and I just put them. I always do it at with the same amount of instructions basically. Take more or less same amount of time for each insert end. So again, if it's empty, I just put both of the start pointer and end pointer equals to a new double list node that I just created, and this one is overloaded to be using perfect forwarding, or basically move semantics, so I can just move data into position. And if not, so there is something in the list, I'm going to create a double list node of the data type. I create a new node, I put the data, basically I create a new node with the data in it, so this is a pointer to it. My end pointer, next pointer equals the new node because I'm inserting end. New node set previous pointer, is my end pointer. So my previous pointer is now end pointer, and my end pointer equals new node. So the current list node next pointer points to the new node. Node we appended have pointer to the previous, and the new node is now the last node in the list. I hope this makes sense. And this is basically insert end just overloaded function. Now we have delete end, which is constant order as well. If it's empty, the list is empty. If the count is 1, that means I have only one. Start and end pointer equals node pointer. Else, I have double this node data type, temporal pointer. I can just again initialize it. Then I have a temporal pointer equals to the end pointer. End pointer equals set the previous node to be the end, because this is delete end, so I'm deleting last one. Setting the previous one to be the end. Set the beginning to a node pointer. So basically my last node, so next node after where my end pointer is pointing has to be a null pointer, and then I can delete the temporal pointer. Of course I have to decrease my count. Insert at position. So to find the position we want, it's the order n. Now the complexity of insert is order C, because I don't need to move anything after inserting. So whatever I searched on internet, overall complexity was order C, so constant order. Of course, this is the overloaded function that can take R value reference. There is the one which takes L value reference. So if the position is less than a 0, it's negative. I don't allow it to happen. If my list is empty, that means I have nothing in it and I want to insert at any position more than a 0, of course. I just create the start and an end pointer to point to a new node, and I forward the data into the new node. I increase the count. Else, if my position is 0, that means I want to use the insert at beginning. If my position is more or equals the m count, so if it's the last or last more than my last one, I just insert end. If it's not the case, now I have to create the iterator. Iter equals this dot begin, because I have to iterate to a position that I want to insert my node. So I go and iterator equals iter plus position. This is the overloaded version of my plus operator. I'm just using it here, so I'm just iterating node by node until I get to the node I want. Now I create a node with a full constructor. So I create a node pointer to the node of a data type, which I can just forward data and iterator. So the get node pointer and get previous pointer, because I just iterated into position that I want. I created a new node with the full constructor is the next node. Next node is my pointer, so if I enter 0, my next node is my pointer. So I just put iterator get node pointer, and my one before I get iterator dot get previous pointer. So I have connected all of the nodes. So I have one node here, another node here. They're all connected to another node, which one I'm going to put into my list. Now link the node at positions. Okay, that's the link. Now I go iterator dot set previous position, set previous pointer to point to a new node. So previous of my iterator is a new node. So because I'm always inserting at the position, but it's one before, because 0 is basically first. And then I'm going to skip twice because I already set the link. So set the previous position to be the new node. So I'm going to skip over the new node, skip again, because we appended the new node, and I'm gonna set the next pointer of that node to be the new node. Because I already have a link with a new node, so I can just go back. I just have to set the link to my next pointer, because this one is set to something that I don't want. So I have a pointers here, I skip twice back, and I set the previous pointer to my new node, and of course I have to increase the count. This is just overloaded function. Now I have deleted position. So again, to get into position is order n, and to delete it's a constant order. So I'm going to, if the position is less than 0, of course it's invalid. If the list is empty, I have nothing to delete. If my position is 0, I delete begin. If my position is last, I delete the end, or one after last. mCount -1, because I'm counting from 1. So if there is one element, my count is 1, but I basically want to delete 0. I want to delete, if I have, like, for example, 5 elements, I want to delete the, I put a position that I want to delete is at 4th, but I have to count -1 because last one is less than a count. If you have the last element, set the beginning and the end to be no pointers. So if there is no more than 1, I just set the pointers and I delete that. Now if there is more than 1, and there is, if it's not end or begin, I'm going to start with create a double list node data type temporal pointer. I make it a null pointer here as well, just initialize it. I'm going to iterator, create new iterator equals this.begin. So I create iterator to beginning. Again, this is the overloaded function of my plus. So I'm going to iterate to the position that I want. And I'm going to put the temporal pointer to be the iterator.get node pointer, because I got node into the temporal pointer. Now I'm going to skip 1 over, and then set previous pointer to be temporal pointer get previous pointer. So basically what I'm going to do, I'm there at which one I want to delete is the temporal node. I'm going to skip over it. I'm going to connect it to one before it. I'm going to skip back, and the set next pointer after I skip back to the temporal pointer get next node. And then I just create, I just delete the temporal pointer, and of course I decrease the count. So move forward, set the pointer to 2 nodes back. You can see, get previous pointer of my temporal pointer, and then skip backward and set 2 nodes forward. So with the temporal pointer, get next node pointer. I know it gets really confusing. Now I have delete at iterator. So if I have some, for example, database, I have iterator already created to my linked list, and if I pass the iterator, this is constant order because I just perform a certain number of steps. If the node pointer is start, delete begin. If it's end, delete end, because of course I cannot have more than end. If the count is last one, just delete the last one. Now, and set the pointers to null pointer. Now, if none of this is true, okay, I can initialize this as well to be null pointer. Now, if none of this is true, I'm going to create a double list node data type temporal pointer. Temporal pointer is the iter.get node pointer. You see, I don't need, I just skip this, that I need to get into position because I'm already at the position. So I could have basically called delete iter in here instead of just performing these steps, because these steps are basically same in here. So I just explained it before. And this one is get start pointer, end pointer. All of them are complexity OC or constant order. Just a simple menu option. Player record.h. This is my class which models a player record. So I have just private variables, 2 strings, 2 integers, first name, last name, level, experience point. Again, this is the move constructor, basically templated, so it takes any argument, but it will give you compiler errors if you don't pass whatever is needed. This is just for convenience that I can forward it and then check, and I can of course take a constant char star, because if you just write string literals inside, it's not a string, it's const star char. My getters and setters, again I have a templated setters with the move semantics. I go into .cpp after players database.h, constructor, then I have a templated version of insert at position, insert at end, and you see searches by name, by level, get average experience of the level range, remove duplicates by name, and print pointers, print database, just the database functionality. Timer is just a timer class we made in a class, user input, and that's user input functionality.h. Now in my menu function there is nothing special, it's just print the menu. There is the menu options in enum, so it's easier to read. Record creation, basically it's order C and it creates a record, player record. Print search menu, this is the menu for search, and I'm going to explain you how my parse input function works after. Now I go through a player record, it's just simple class, getters and setters, constant order, constructors, constant order, players database. I have this function populate, which basically just puts some player records into a database. We can just disable it if I'm going to put a proper implementation. Then I have the get records, just get average experience. Now this is the function that returns average experience of the player, and this is the overloaded. It's order n, and the more players of a certain level there are, the longer it takes. Just initialize my double sum and integer count, and what I'm going to do, I'm going to iterate with my iterator that I created for my record list, and I'm going to compare it to player's level. If it's equal, I have a match, increase the sum, and increase the count. Then if the count is 0, that means that no player matched criteria, I return 0. If it's something in there, I just return average, is a sum divided by count. Same for the two parameters, I just do a different comparison. Now I have my search by level, again it's order n, because the more players I have there, the longer it takes. Search by level with the criteria. If the level, again I'm going to iterate through my double linked list of player records with my iterator, and I'm going to populate my vector that I'm going to return from the function. So whatever I found that matched the criteria, I'm going to put it into a vector of player records, and I'm going to return it. Same with the search by level with the criteria, two integers. Now I have search by name, again is the order n, because the more I have in my database, longer it takes. Takes string. and whatever matches. So if my iterator.get first name equals the name that I just passed, we have a match. I have a vector that I'm going to return from the function. I'm going to pass it into a vector. This is just overloaded function. Now this print function is just for my convenience, that I don't need to be printing vector outside in a loop. I just pass it into this function and it prints the vector. It's a constant function, so I know it doesn't change anything from my database, and it takes the vector of player records at players to print, so I just pass a pointer to it, iterate through it, and prints the players basically. Print database, all of the prints have order, and the more data is in them, the longer it will take. Remove duplicates. I'm going to show you the case where I'm going to remove the check for duplicates from my initializing how long it will take. But this is basically this function just removes duplicates and it iterates. It iterates for the record vector dot iterator, so the vector of the iterator, and then duplicates dot begin dot end iter plus plus this dot remove duplicates, so it calls another function that is here, remove duplicates by name. So because I store every duplicate when I'm inserting into my database in a vector, so my insert is order n, but I can make it a constant order, and I show you what is the difference in the time. Now this will initialize count to be 0. I'm going to iterate again through the record list iterator and from beginning to the end, and if there is a duplicate, so if the first name and last name matches, and if my count, this is important, is more or equals to 1, because I always want to leave 1, I don't want to remove all of them, then I'm going to remove 1. So iterator equals iter plus plus mRecords dot delete iter. So that's the function I showed you before that deletes the record at the position of iterator. Now this is check for duplicates. This is the function which will check if when I'm passing a player record into my database, if it's already a duplicate, and I can puts it into my vector, because otherwise my remove duplicates would be order n squared. So this will basically takes from n squared to order n, but that's why check for duplicates is order n, because I have to check through all of the records. Here I'm using the 4 loops and they're auto, so they for constant auto at player means that for each player in my m player records I'm going to loop, and also this one is the same. So I'm just showing you the different way how I can use the new C++11 feature, and I was testing it for if it's faster or slower, and it was giving me the performance is the identical. And then I just push the duplicate down I found into my vector of duplicates, and then I have a delete record at position, it's constant order, and I print duplicates, it's basically order n. Now I'm going to my user input, and here I show you the function of parsing. So I created 2 rejects, which ones are static constant strings. This is just R in front of string means that I'm using raw string literals, so whatever is in regex, I don't need to escape with the double backslash, so it's just for convenience. And then another feature of C++11, and I have just user input, expected input, user input with string. Here I'm just going to check if I'm returning integer and I'm passing some string into my function, if that string will convert into an integer, and if no, then I just input conversion from string to int failed, please enter integer, and it will call the function again, so it will just loop until you enter integer. Now my parse input, the complexity is O(n), because the longer things you pass into it, the longer it will take. So I have a regex. I just create the regex and put my regex range, it's basically a string, into my regex. Then I have a vector integer to return, that's my vector that I'm going to return. This vector.reserve is just that I reserve vector to be of size 2, so because I know I don't need more than that, and an integer that I initialize to be a 1. Now if my regex match the string that I pass into my function, that means that I can that there is some digit followed by this and then another digit. I'm going to go back down, and this is I create the array of submatches 1 and 2. So what it does is I'm going to extract these digits and these digits that are before and after this symbol. And after I extracted them, I'm going to iterate through all of these matches that I have. I have in this case only 2, so it's only 1 and 2. And while I'm not at the end of the matches, so I'm going to extract 1. This is just that I'm going to check if it matches a integer. It's just for convenience, not really necessary in here because I know that it should be after I went through a regex. And then I'm going to push it into my vector, and then I'm going to just increase it for while loop. In the other case, if this didn't match, I'm going down and I'm going to put regex equals regex digit. So at least if he didn't enter the 1 and the second digit, I'm going to assume that he entered 1 digit. I'm going to check for that. Okay, this pass. I'm going into, again, that just for convenience. I don't need this because I know that it should be a digit, so it should basically be an integer if I convert it from string to int. But I'm just putting this check in here, and I'm going to push it into my vector. And then I'm going, else there is nothing, I'm going to push back -1 into one vector, that I know that if I have nothing matched, then in my vector is -1. And how it's gonna play in my menu options, if I call this function search by level, I'm going to check the vector of results that I got. If it's -1, I know that I have invalid input there. If the size is 1, so I have only 1, I know that there is only 1 digit, I pass it into my search by level function. If I know that there is 2, because if it's not 1, that of course it can be only the third option, then I'm going to pass it into my search by level overloaded function with 2 integers. So I have a little timing demo here that you can see time differences in the in the move and copy constructors, and a bit about them. What is the difference? So let's say I'm going to first create a 10,000 of my player records, And I'm going to create with my copy constructor, because I know that int, and two strings is the copy constructor. So I'm going to run this, and it should take, it just takes 222 milliseconds. Now if I'm going to run it with my move constructor, you can see the difference is only 127 milliseconds, and that's only for 10,000. If I bump it, this will be only 1 second 189 milliseconds, so that's for 100,000 constructors if I'm going to construct 100,000, and this is with a copy constructor. So for 100,000 it will take about 2 seconds. So there is almost double speed if you construct. It's about 70% faster, or let's say 65. Now if I'm having a vector of strings and I'm going to have a 2000 strings in the vector, let's say I want to push it into, let's bump this down, let's make it 100 for us for a first. I want to push it into my vector, so that's the show you the difference between move and copy constructor. So I'm going to type this, make 100 of vectors that I have 2000 EAs in them, and it took 4 seconds to push them in. Now I have 100 of vectors, and I'm going to use this move semantics, but there is a little catch. I can move only if I know I want to use this vector after. If I know that I'm going to use this vector, that I need these values, I cannot move, because once I move from it, it will be only a null pointer. So, and there is it, difference in speed from 4 seconds to 6 to 5. The larger data you move in, the better performance you get. If you just move in few strings, you won't gain too much, but it's still some gain in the speed. So that would be for the demo. And of course, if you reserve, you speed up vector. I was testing it before without reserve. For example, I was passing 100,000, was going from around 2.5 to about 1.2 seconds, so it was saving time in not calling the reallocate memory function for a vector. So I think I covered everything, and that's how my main looks. I just have a simple main function which run database. Oh, of course I didn't show you what would I save in case of constructing and pushing into database. So I have this test database, insert it there, and I just going to, let's say, insert this record to push. So I create a test database, initialize it to some value, create some player record, and let's say I'm going to push it at the end. So I'm going into my function, and as you can see, this will check for duplicates and automatically search for them. So if I disable this, insert at end position, it also has a move semantics already in it, and I go back into my main menu. I'm going to, for example, start with 10,000 elements in it. I'm going to run. Oh, sorry, I forgot to disable my database. So I'm going to run, and as you can see, it took around 146 milliseconds. Now if I'm going to bump it one more, that will be around 1 second 46. So 1,334 milliseconds. Now if I'm going back to my function and I enable this, now if I run my main, so that has to check if there is some duplicates for 100,000 elements, it was 5.495 seconds. So we can see what is the difference between constant n, order n inserts. So if I would want to optimize my database, I would disable probably check for duplicates, and because I know that there won't be many of them, but in real life you won't be able to add duplicates into database. So now I think I covered everything that I wanted. This is just the run database, simple